Hey guys, welcome back to our 100-day challenge for DevOps and Cloud. And today we are going to talk about Kubernetes concept and its architecture on day 13. So welcome again. And as you know that Kubernetes is an essential component of modern DevOps and cloud-based application management. That's why we are covering this in too much details. We will explore the key concepts here, advanced features, and various Kubernetes architectures. Now let's talk about what you are going to learn from today's session. So first we will understand the Kubernetes fundamentals that will help you to acquire a solid understanding of the fundamental concept of Kubernetes, which includes pods, services, replication controller, deployment, container runtime, and help you to work with containerized applications effectively. Next, we will explore advanced Kubernetes features such as stateful sets, daemon sets, and config maps that will help you to gain the knowledge needed to address complex deployment scenarios and applications requirement. Next, we will talk about the Kubernetes architecture. So here you will be able to explain the core components and architecture of Kubernetes, either it is single host or multi-host or in the cloud. So you will be able to explain each and everything about the Kubernetes architecture. So you will understand the role of control planes and worker nodes in Kubernetes. Next, we will compare these environment like on-prem and cloud deployment. What are the key features? And we are having different kinds of environment available and how we can use them as per our requirement. Next thing, we need to understand the importance of Kubernetes in DevOps. So here you know that how Kubernetes serves as a crucial tool in DevOps practices that we will see, and then you will be able to recognize how Kubernetes automation, scalability, and reliability contribute to efficient application deployment and management in DevOps workflows. Next, it will help you to prepare for further learning. Like if you, by the end of this session, you will be equipped with the fundamental knowledge which is needed to explore Kubernetes in more depth. So what will help you? So it will help you whether you are looking for a career advancement or the certification, or you are looking for advanced coursework in DevOps and cloud computing. It will help you and aware you for the next steps in your learning journey. So without wasting time, let's get started. Now let's talk about something related to Kubernetes Basics. So what exactly it is? It is an open source container orchestration platform for automating deployment, scaling, and management of containerized application, or we can say it will help us to orchestrate microservices and containerized application. So this is the definition. You can use it. Next thing, why we need Kubernetes, right? So actually Kubernetes provide a number of rich features. That's why we are using these features are like automation, scalability, and high availability. When we are talking about automation, it automates many of the tasks which involved in managing containerized application like deployment, scaling, or load balancing. If we talk about the scalability, Kubernetes can scale your application up or down automatically based on your application demand or requirement. This can help you to improve the performance and availability of your application. Also, Kubernetes ensure that your application are highly available, even if some of the nodes in your cluster fails. Even your application will up and running all the time. That's why we need this Kubernetes very much in our modern environment. Next, we are having the benefits of using Kubernetes. So Kubernetes provide increased agility and innovation. It reduce the cost and also it improved application reliability and security. So that's why we are using Kubernetes because of its benefits. Now let's talk about the Kubernetes basics concepts. So first concept we are having pod. So what exactly the pod is? Pod is a basic unit of computing that Kubernetes manages, and a pod is a group of one or more containers which share the same storage and networking. So it's like in your pod, it can be one container or it can be a group of containers within a single pod. And it's a basic unit in Kubernetes that you create or destroy. Next concept we are having nodes. Nodes are like your virtual machine or physical box where these pods will be created and run. Okay. And inside that pod, you will have containers, and in these containers, application will run. Next concept we are having services. What exactly the service? It's an abstraction that defines a logical set of pods and a policy that will help this application to access. So services provide a way to expose your application to the outside world. If you want to use this application over the internet, then you need to expose it on some port. That's why this service come into picture when you are going to expose your ports to the outside world. Next concept we are having deployment. So deployment is a declarative object that describes the desired state of your pods, and Kubernetes will create or update the pods as needed to match the desired state with the help of this deployment. Next concept we are having replica sets. What is replica sets? Replica set actually ensures that a specified number of pods that you define are running at all the time. If a pod gets fails, the replica set will create a new pod to replace the terminated one. So it will make sure that whatever number you define, it will be created to the desired state. Next concept we are having container runtime. What exactly it is? It will create containers and manage the containers within the node, we can say. And this is like a example of Docker or containerd, whatever container runtime your Kubernetes uses. So these are the basic concept related to Kubernetes. So now it's time to talk about Kubernetes architecture. So before deep diving into that, first let's understand the component of Kubernetes architecture. Okay. So first component we are having control plane. As the name saying control, that means it controls everything within the Kubernetes. Normally there are two names. Either we can tell master or we can say control plane. So in this one we are having four basic component we can say, and but we are also we can have some advanced component or we can say the complex component of this node. So basic components are API server. Next we are having etcd. Next we are having scheduler, and then we are having controller manager. Okay. So these are the four basic components we are having within the Kubernetes, which do all the work managing everything related to the pods, containers, and take care of scheduling, take care of other controllers as well. Even when we talk about the API server, it's a main entry point for interacting with Kubernetes. If we talk about controller manager, that manages other controllers. If we talk about scheduler, which manages the scheduling of pods on which node it will go. If we talk about etcd, it's it's only communicate with API server and holds key value pair is in its database. Okay, so these are the core components of control plane. If we talk about the worker nodes, so worker nodes are the machines on that our pods are running. So worker node communicates with the control plane to receive instruction and report on their status. So whatever pods will run, it will run inside this worker nodes. So worker node also have some key components like it is having kubelet, kubeproxy, and also it is having container runtime. These are the key component. Then the containers come into picture, which will run inside this one and the pod, which we already talked about. Next part is very important related to Kubernetes architecture. That's how these communication will be established between the control plane and worker node. So for communication between control plane and worker node with each other, we are using some API. So one is Kubernetes API, which is the main API, which is used to interact within the Kubernetes. Next is kubelet. You see here, this is the component which is stored on or run on worker node, but it is responsible for managing the pods on. So if you see kubelet, kubelet is an agent that runs on each worker node and is responsible for managing the pods on that particular node, and it also interact with this API server. So these are the core components. Now let's talk about Kubernetes architecture, how we can define it. So here we are going to talk about some high level Kubernetes architecture. Let's define it, how we can draw it. So here we are having master node. On this master node, we are having API server. And here we are having control manager, CM. Here we are defining scheduler. Okay. And we are having etcd database here. And you know this etcd database is only communicate with this API server, not other component of this Kubernetes infrastructure. So this is how we define our master node. Now let's talk about the worker node, how it will look like. So it can have one or multiple. Let's talk about only one worker node at this point of time. Otherwise, you can draw other also. So the main component we are having kubelet, kube proxy. Then we are having container runtime. Let's example of Docker here. We are taking Docker, and inside this host we are having pods. Okay, and then within this pod we are running some containers. This is how we draw our Kubernetes architecture. Now, as an end user, here we are talking about the end user. Okay, when it need to communicate with Kubernetes, it needs some tool. The tool is kubectl or kubecontrol that we talked in our previous session. So what will happen? It will communicate this API server, and based on the command, it will function accordingly. So how the communication will take place? This kubelet is also communicate with this API server here. This control manager will communicate here. Scheduler will also connect here. And how the connectivity will be inside this worker node. This kubelet can communicate directly to the containers, or it can communicate to these pods as well. And we are having kube proxy, which will communicate with this kubelet, and also it will communicate with these pods. So what exactly this kube proxy do? Now let's understand the each component, what exactly it do. First, let's talk about the API server. So in short, API server commits all. So API server is the only component from the work. So what exactly the API server? So in here you can see API server is the only component from the master node which communicate with kube control and kubelet into the worker node. Now let's talk about one by one. First, let's understand the API server. If you see here, API server is only component from the master node which connects with the kubelet from the worker node. If we talk about controller manager actually manage other controllers, like we are having different controllers, the application namespaces and node controllers, etc. So it manages that thing, and it's also communicate with API server. Next, we are having scheduler. Scheduler, what exactly it do? It identify the right node to place a container based on resource limitation. So it will always look that which is the suitable node for any container. Based on this, it will place the container on that particular node. Next, we are having this etcd. So it's a critical part of Kubernetes, and it's a database that stores state of the cluster nodes and also workload information in a key value pair. When we are talking about key value pair, what exactly it is? Like if you we have seen some files, right, where we define like kind is a pod. So here key and its value. So similarly, if we need to define name of the container, we will define like this way. So it is the key value here which is stored in this one, and also it also store the state of the cluster nodes. Okay, next we are having kube proxy here, right, that we did not talk yet. So kube proxy actually runs on each worker node to deal with the individual host subnetting, and it also exposes services to the internet. Pod, you already know, it is the basic unit. Containers where your application runs. Docker is a container runtime which create these containers within the pod. And here we are having queue control or kubectl. It's a command line tool which help us to interact with Kubernetes. So these are the key components and the architecture of Kubernetes that we have to understand, and it's a high level architecture diagram of any Kubernetes cluster. Here you are having this here. If we go in a cloud, we are having cloud control manager here. Now it's time to talk about some advanced concepts. So the first concept we are having is stateful sets. So what exactly it is? It is used for stateful applications like where we need to keep our session active for the next phase. So it provide stable network identities and storage for that one. So this is very useful for stateful application. Next tool we are having daemon sets. So daemon sets, what exactly it do? It ensures that a particular node runs on all the nodes in the cluster, which is oftenly used for cluster-wide tasks like logging or monitoring. So it ensures that thing that particular nodes run on each node. Next, we are having config maps. So config maps actually separate configuration data from application code, which enhance maintainability and flexibility. So these are the key concept, or we can say advanced concept of Kubernetes. So these are the advanced concept of Kubernetes. Now it's time to compare Kubernetes environment in different scenario. Like we have taken three scenarios here. So first scenario we are having Kubernetes infrastructure is configured in a single host. It can be your virtual machine. It can be your physical host. Okay. Next environment is multi-host on-prem Kubernetes infrastructure, where you are having multiple nodes like master and worker node, but these all infrastructure is configured in your organization itself. Next to environment is multi-host cloud Kubernetes environment, where these multi-host Kubernetes environment is configured on any one of the cloud platform. So first we are talking about the deployment environment. As I mentioned, here we will have single machine. Here we will have on-prem data center. These machines are hosted there. And in the last one, we are having this configuration on cloud infrastructure. If we talk about the scalability part, so as we are having only a single host, so we are having some resource limitation here. So here we are having very limited scalability option. Here, if we talk about we are having multiple hosts, it's scalable, but when we are talking about cloud, it's a highly scalable because we are having the option to pay as you go. So you can configure as much as machine you want. Next is control plane. That is our master node. If we are having only single node, that means we are having only one node where we need to install all the components. So we are not having option to distribute those components against other nodes, right? But in the second option, we are having that distributed control plane option where we can distribute our component to different nodes. If we talk about the multi-host cloud Kubernetes environment, here we can use managed control plane, which is provided by different cloud provider. We are having from Google, we are having GKE, that is Google Kubernetes Engine. If we talk about Amazon or AWS, there we are having EKS. If we talk about Microsoft Azure, here also we are having Azure Kubernetes Service. So these are the managed control plane. So you just need to focus on your workloads, not on the management control, means control plane or master node. Next, about the resource management, as we are having first scenario, only the limited control here because of less nodes. Here we can enhance more control because we are having multiple hosts here. In the last, in the cloud, control is done by cloud providers. You just need to focus on what type of container you want to run or application you want to run. You need to focus on your workload only. If we talk about the networking configuration in single host, it's a very simple. If it is multi-host, here you need to provide custom network configuration. It is a bit complex, but not too much. If we talk about the cloud one, here cloud provider do all the networking part. Next is hardware requirement for the single host Kubernetes environment. Very minimal hardware we need is the configuration part. But in the multi-host, we can custom that hardware setup based on our application workload. In the cloud infrastructure, yes, hardware requirement is fulfilled by the cloud provider, so we no need to worry about much here. Next is maintenance complexity. In a single host, it's always easier to manage Kubernetes infrastructure, but in multi-host it requires more management, and in the cloud one, provider manage everything related to the controller. We just need to focus on workload, as I mentioned. Next is cost part. in a single host, always lower cost. If we have multiple hosts, it's a potential bit higher, but in the cloud, it's based on your utilization. So here, always you will have the variable cost. If we talk about the high availability in a single host, always there are a limited availability, because if that host goes down, then you don't have any other option to run your workloads. If we talk about multi-host, we are having enhanced clustering. Here we are having more availability than the single host, but still it's a lesser than the cloud one, because cloud provide built-in high availability, and their resources up and running 24 by 7 as they commit as per our SLA. If we talk about the use cases where we can use these infrastructure, if we talk about a single host, it's always good for development and testing purpose, not recommended anyhow for the production one. If we talk about the multi-host, you can use it for the production applications as well. If we talk about the cloud one, it can be used for anything, whatever you want based on your requirements. So it's useful for production application, and it's easy to scale. If you want to test also, you can easily do it, and then you can expand your infrastructure. So this is how we are having different infrastructure or environment for Kubernetes that we can define based on our requirement. So now it's time to talk about benefits of Kubernetes in DevOps. So as you know that Kubernetes helps DevOps practices by automating deployment, scaling and management. So first benefit, we are having automation. So it automates many manual tasks, reducing the chance of human error. Next is scalability. Kubernetes scales applications effortlessly in response to the demand, and the reliability also it provides that ensures high availability by distributing containers across multiple nodes. So these are the key benefits of Kubernetes in DevOps domain. That's why we are able to deliver software faster. Next thing, now let's summarize today's session. So Kubernetes is a fundamental technology in DevOps and cloud computing, and it also offers powerful tools for container orchestration and application management. Now the thing is how you can move forward with the DevOps and cloud journey. Just explore more in depth Kubernetes, and also you can do some certification or some advanced course related to Kubernetes to grow faster. So see you in next session where we are going to talk about Kubernetes resource management, Kubernetes networking and storage. Till then, happy learning, keep exploring, keep transforming. If you like this video, click on like button, share with your friend, and don't forget to subscribe.